All right, folks, agriculture is in full swing here. We got ourselves a crusty old plow truck. This is a 2002 International 7400. It has a DT466E engine. The customer complaint is that if you leave it sit for any length of time, let's say 48 hours, it will crank and crank and crank until the cows come home, but it will not start. And it's been doing that for as long as I've been working on it, which is probably about 3 years. And it used to be, if you hooked a battery charger up just for a few minutes, let's say 5 minutes, it would start right up. But now the problem has gotten worse, and the battery charger no longer does the trick. You got to give it a little shot of ether. And as soon as it starts, it runs fine, drives all day. You can shut it off and start it right back up. But if you leave it sit overnight, you're right back where you started. I've done some testing, but at this point I do not know what the problem is. I've never seen anything quite like this, so I figured I'd get the camera out and maybe I can help somebody, or we can learn why diagnostics is a terrible way to make money. Either way, should be interesting. Let me show you what I found. Just to demonstrate. That's what it does. This is a HEUI engine. I believe that stands for Hydraulic Electronic Unit Injectors. So the injectors are controlled by the computer, which is down there behind the oil filter, and it fires them through an IDM, an injector driver module. But the mechanical force that opens the injectors is high pressure oil, engine oil, which is created by this mechanical pump here. It goes through that high pressure line into the head and it's poured out to the injectors. For all intents and purposes, it works the same as a 7.3 power stroke. So far, I know that the engine cranks and it has good cranking speed. I don't hear anything weird or irregular with the engine. Once it starts and runs, it runs fine. It has reasonable fuel pressure and reasonable fuel flow. The fuel system's it's a little complex. It goes through a strainer and then through a filter. Then there's a mechanical pump here on the back of the high pressure oil pump. And then it goes through a port in the head, and there's a regulator built into the back of the head before it drains back to the tank. I've taken a fuel sample. The fuel looks good, smells good. I don't see any problems there. I don't really have a good scan tool for these trucks, but as far as I can tell, there are no codes. And when I'm cranking, I do get a signal on the tach, which usually means that the cam position sensor is working. But just to be sure, I got the picoscope out and the cam sensor is working. Show you that. So there's the cam signal there, the blue. It looks normal to me, but there are some problems that I can see. The issue seems to be that it will not build ICP pressure. It won't build the high pressure that it needs to fire the injectors. So the green here is the voltage from the Icp sensor, and the red is the amperage through the IPR valve. The Icp sensor is this guy here. The IPR valve is down here at the bottom of the high pressure oil pump. They work together to regulate the pressure to the injectors. And the Icp sensor basically tells the computer what's happening. So it uses the Icp sensor as feedback to control the IPR valve. This does not match what I was expecting to see. What should happen, I believe, is key on, engine off. The current to the IPR valve should be about 200 milliamps. And while you're cranking, that current should slowly rise up to around 500 milliamps. And the Icp voltage, which is the pressure of the oil, should also rise. And once it gets to around 1 volt, the engine should start. Now in this capture, I have the ICP sensor unplugged. So the computer should default to, I don't know, some pressure that's good enough for it to start. But the red line here is, I think, what's interesting. That's the IPR current. And the cursor here is at 200 milliamps. So key on engine off where we should be. Then we start cranking and it slowly climbs. And then it just falls off to 0. And then it comes back to our baseline, slowly climbs, falls off to 0. And it does that consistently. But what's interesting is the frequency matches the RPM of the engine. So you can kind of see it in the cam sensor signal here too. You see it sort of fails to pull the ground here and here. This dropout is consistent with 1 rotation of the camshaft, 2 rotations of the engine. I don't know why, but that's what I'm seeing on the scope. So I don't know, are we losing a ground or a power? Is the computer just goofy? I don't know what could cause it to drop out consistently like that. Doesn't make any sense. Well, this time it did set a code. 2 of them actually. So we've got a 612. Not sure what the 14 means, but the P means previous, so it's a stored code. And then a 2023. Well, that's interesting. Didn't have that before. So it says here, flash code 612 indicates that the ECM has monitored the CMP signal, the cam position signal, and the signal is incorrect for the programming in the ECM. This means that the ECM does not recognize the signal generated from the timing disc and the cam position sensor. When this condition exists, the ECM does not send a fuel demand command signal, so it doesn't turn on the injectors. Possible cause is ECM has been accidentally replaced with incorrect ECM. That's not going to be the case here, I don't think. Incorrect signal due to defective CMP sensor or incorrect air gap between CMP sensor and the timing disc. I wonder if I have a spare cam sensor. I know for sure I've got one for a 7.3. I wonder if it's the same. I think that's the ticket. Pays to be a hoarder, I guess. This is used, but might be worth trying. So the thing I'm concerned about is this little guy right here. Right here. Right here. It didn't stay pulled to ground. This should be a Hall effect style sensor, so it should be a square wave. The thing is, I thought it was consistent, that it was once every cam revolution, but it's not. There's 24 teeth on the cam trigger wheel, but I counted there's only 17 spaces between these 2 events. There's something here, there's got to be. I just can't figure out what it is. So once the engine is cranking at a steady RPM, it's perfectly consistent. We get the little extra spike here, 2 pulses after the narrow pulse, every time. And every time we get the pulse in the cam sensor, we also get it in the ICP sensor, and the IPR valve drops down to 0. Those things have to be related. I don't know how. I tried swapping the cam sensor, there was no change. I tried an external ground, there was no change. I also tried removing the cam sensor and just poking around in there with a bore scope. Cam sensor's right there. I don't see any problems with the tone ring at all. So it's got to be something that is consistent with the timing of the engine. And the only thing I can think of is the injectors. I mean, other than the cam sensor, what else happens consistently on every cam revolution? Anyway, I have unplugged the injector harness from the valve cover. We're going to crank it. We're going to see if there's any change. Alright. Let's see. Yeah, that's what it should do. Okay. So we saw before the ICP pressure would build, it would hit that glitch and then it would drop out. Now it's building consistently, just like it should. Same with the IPR current. Going up to, I don't know, probably 400 milliamps. That's what it should do. Yeah, you see it got up about 2 volts there. That should be plenty for it to start. Of course, it won't start without the injectors plugged in. Do we still have the glitch in the cam sensor? There's the narrow. There's the narrow. No, we do not. All right, fantastic. So we've got something going on with the injectors, or the injector harness, looks like. Interesting. Why don't we have a code for that? All right, let's move some things around. I've got I've got 3 amp clamps. 1, 2, 3. Only one of them works, so I think these might have been a victim of our recent lightning strike. Anyway, let me hook on with the one good amp clamp. Let's see if we can figure this out. The good news is the problem does seem to be related to the number 1 cylinder. The bad news is I still don't know what the actual problem is. There's the firing event right there. It maxes out about 6 amps, which is actually pretty reasonable. Looking at my waveforms for the power strokes, they pull around 8 amps. So I don't think we have a shorted injector or anything like that. I'm wondering if maybe, and I'm not sure how this is possible, I wonder if maybe the control side of the number 1 injector is shorted to the 5 volt reference. So looking at the wiring diagram here, the cam sensor, the ICP sensor, and whatever else, engine oil temperature, coolant temperature sensor, they all share the same 5 volt reference. So I wonder what would happen if we just cut that wire to the number 1 injector. Got the answer right here. Oh, somewhere where it's easy to splice. Will it start? We're only going to have 5 cylinders. No. God dang it. What's the problem here? I moved my back probe on the ICP sensor from the signal wire to the 5 volt reference. And something very interesting has happened. Check this out. Now it wants to run. So I don't have any idea what's going on. We're having a real good time over here, folks. I'm about 5 hours into this and I still have no idea what's going on. So I don't know why it's trying to run now that I plugged into the 5 volt reference side of the sensor. It's kind of a good thing though, because it gives us some more information. So if you look here and find a narrow pulse, there's one and there's one. Between those, there are now 6 humps. So all 6 injectors are affecting the 5-volt reference. Does that mean we have a bad ground? Or a bad PCM? I don't know. I really don't. I don't have any explanation. Oh boy, what is leaking under here? Well, folks, some time has passed, and I have no more answers than I had before. This thing is a mess. It runs, but requires quite a bit of that. Everything warmed up, it should restart, no problem. I've peeled and poked and prodded and cut wires. I even tried cutting the 5-volt reference and the signal return and subbing in 5 volts from this benchtop power supply. It made no difference. I tried substituting a value for the IPR valve from the benchtop power supply to force it to build high pressure for the injectors. Didn't make any difference. I just don't know. I think it needs the magic box. We're going to try something here real quick because we haven't beat a dead horse quite long enough. I'm going to start it up, if it'll start, and then I'm going to unplug the Icp sensor, and then we're going to try to ground it through a test light and see if we still have voltage spikes. Well, this is pretty interesting. At least it is to me. You're probably all asleep. So the engine is running. The blue is the Icp sensor. Right here is where we unplug it. And it should drop to 0. But it doesn't. It still has these little spikes. And we were fumbling along. And eventually we plugged in a test light. Let's go all the way to the end. Come on. There's the end right there. So I know for sure that the test light was plugged in here, and we still have the exact same spikes. It's spiking up to about, I don't know, 400 millivolts, somewhere in there. So that can't be an induced voltage. The test light should be enough load to ground that out. That's got to be coming back from the ECM. I mean, where else could it possibly come from? Unless a wire is shorted to the injector, but it would have to be shorted to all 6 injectors. That doesn't seem possible to me. 1 injector, sure. 3 injectors, maybe, because they're set up in groups of 3. But all 6? There's no way. So the yellow here is the injectors. You're only seeing the front, well, 1, 2, and 3. 4, 5, and 6 are on a separate circuit. Yeah. Anyway, the other thing that's interesting here when it's running versus when it was cranking like before. Either the timing has shifted or the duration of the injector pulse or something is different, and the spike, the voltage spike, now lines up with one of the peaks on the cam sensor instead of being lined up with one of the valleys, so you don't get that extra peak. Yeah, that's it, folks. I think it needs the magic box. I really wish there was a Navistar engineer here so I could punch him in the face. This is the stupidest design anyone could possibly come up with. I want to check the powers and grounds for the computer, the ECM. Well, it is buried way down here on the back side of the engine. I can't even get the camera in here to show you guys. Anyway, there's a plastic cover over top of the connector. It has a plastic nut with a 1/4 inch square drive. That's stripped out. Then it's stripped out on the bolt. That's the shiny thing you can see there. So I ripped that off and I tried to turn the bolt. The bolt turns, but whatever it threads into inside the ECM, that's stripped out. So there is no way to get that connector off the ECM without cutting the head off that bolt. And that's a one-way path. Once we do that, we can't put it back on. At least not securely. I called in a local Rust Belt shaman to recite some secret incantations. And long story short, I got the fender off without breaking any bolts. And that allows me to access, maybe, if you can see it, access the ECM connectors. All right, part of the problem is I had the wrong wiring diagram. Finally found the right one. On this ECM, there's two connectors. The top one is the engine side. The bottom one is the chassis side. All the powers and grounds are on the chassis side. There's 4 powers and 4 grounds. This test light here is one that I made. It has a regular H11 headlight bulb. It pulls about 4 amps. So it should be a pretty good load test. It's currently hooked to the positive terminal of the battery. And we should have power, or we should have ground, I should say, on pin 1 of the PCM. This is pin 1 right here. That one's good. Should also have a ground on pin 2. That one's good. And then pin 23, 21, 22, 23, that one's good. And 42, that's 41. That one there must be 42. And 42 is good. All right. All right, we should have power on pin 24, 21, 22, 23, 24. That's the ignition power. And then we should have 21, 22, 22, 22, there it is, and pin 41. Okay, those 3 come through the ECM relay. I think that's all she wrote, folks. In my semi-professional opinion, she needs a computer. It's also the IDM, the injector driver module. It's all built into the same box. Regardless, I think it's junk. Wonder what one of those costs. I bet that's $2,000 at the dealership, maybe $2,500. I think that's how that goes. What a stupid design. The screws in the middle of those plastic caps, they were all rusted and mangled. I managed to get both of them out, but I went ahead and installed some new ones. Put a little fluid film on there for the next guy. But like I said, that top connector, it's not coming out of there without cutting. So that'll be fun. The good news is it probably won't be me I have no way to program a PCM. I don't know if a used one can be installed without programming. I doubt it. So it's probably going to be the dealership fighting with that thing. International probably has the worst quality wiring of any of the big truck manufacturers. But one thing they actually do right is they run all the powers and grounds for the PCM and the IDM straight to the battery. All right, we got everything under here. Close enough. I know there's an adapter for my fuel pressure tester down there. Get that out to remove it. Man, if you're an international mechanic, you work on these junkers every day, my hat is off to you. I don't know how you do it. I wouldn't last a week. They'd be hauling me out in a straitjacket. Come on. What's the problem? It's a little broken is the problem. There it is. Come on. Well, add that to the list of things you can't do with one hand. Putting a lid on a battery box. All right. Let's go lick our wounds. If I never see this thing again, it'll be just fine with me. You guys ever seen anything like this? I never have. I've seen some weird stuff, but this is a new one. Let's do a quick recap. I feel like it's been kind of hard to follow along. This HEUI injection system, it's tough to see how International thought this was a good idea. You use a pump to pressurize oil. You regulate the pressure through a solenoid valve, an IPR valve, and you monitor the pressure through an Icp sensor. The injector itself is essentially like a little mini hydraulic ram, and basically you need more pressure to run higher RPMs. I believe the pressure just basically controls the speed that the piston in the inside the injector moves, and more pressure, more speed. There's a solenoid valve on the injector itself that controls the amount of travel or whatever. It doesn't really matter. Anyway, like I said, this is what should happen when you're cranking. It should close the IPR valve and build ICP pressure, and once it gets to around 1 volt, should fire the injectors, and then it kind of settles in, and the computer uses the ICP sensor to control the IPR valve. It's got to be a closed loop system. As the engine RPMs change, the flow through the pump changes, so this thing has to constantly be in control. Fortunately, on our truck, as soon as it fires that first injector, it spikes the voltage on the ICP sensor, and then it shuts down the IPR valve. It shuts off the regulator, basically drops the pressure to 0, and it slowly closes the regulator, tries to build that pressure back up, and then as soon as it fires another injector, you start back over at 0. What's kind of hard to understand is, why does the engine run? Here's my theory. You spray it with ether, and the engine runs off the ether, and you get up to a high enough RPM to where these spikes are close enough together that it kind of averages out inside the computer, and it stops seeing spikes, and it just sees kind of an average voltage. And actually, when you start it with ether, it has no throttle response for a while. It takes about, 3-4 minutes for the throttle to start controlling the RPM of the engine. And he said if you drive it, it has no power, which to me means that even though it's running, the computer is not really controlling the ICP pressure, because it has to raise that pressure in order to raise the engine RPM. Anyway, here's 5 reasons why I think the problem is the ECM. Number 1, we have interference from all 6 injectors. Remember the way that it's wired. The injectors are controlled in 2 banks. There's a common power feed for 1, 2, and 3, a common power feed for 4, 5, and 6, and then each injector has an individual control wire that pulls to ground. I could understand 1 injector causing interference, I could understand 3 injectors causing interference, but 6 injectors, I don't see how that's possible. Number 2, we have the voltage spikes on several different sensors. I can understand it being shorted to the ICP sensor or the cam sensor, but to see it on all the sensors, I checked the accelerator pedal position sensor. It shows up there too. Number 3, we don't have the voltage spikes with the injectors unplugged. So that means it can't be a shorted wire between the injectors and one or all of the sensors. Because as soon as we stop having current, we stop having those voltage spikes. Number 4, with the ICP sensor unplugged and grounded through a light, we still have the voltage spikes. That means that the voltage spikes are capable of carrying a load. I think in that case it'd be like a 1/4 amp or a 1/2 amp or something, you know, because it's like 4 volts through a small test light. It's not a lot of load, but it should be plenty of load to take out, you know, induced voltage. It should ground that induced voltage, no problem. Number 5, this problem only happens on a long cold soak. If it was, you know, wires shorted together or induced voltage, it should happen all the time, right? But it only happens if you let the truck sit for 48 hours or more. Yeah, what a weird failure. Here's the part that's really gonna bake your noodle. The truck's been sitting for just about 24 hours. It's completely cold. I bet you it'll start right up. Isn't that crazy? Oil pressure gauge even works today. Unbelievable. I don't know, folks. I really don't. Doesn't matter. Needs a computer. That's my final call. It's probably not going to get one, if I'm being honest. I doubt they're going to spend the money. I mean, it still runs. It's just kind of a pain in the butt to get it started if you leave it sit for too long. As long as you start it every 24 hours, it seems to be good to go. Tell me what you think down in the comment box. I got to move on to the next project. Thanks for watching. I'll see you next time.